In this video, I'm going to talk about cryptographic hashing. Not necessarily really a programming topic per se, but something that you will be using in your next assignment. And it's also very pertinent to anyone who's a CIS major because it has a lot to do with security. And it also gives you an idea of some of the more sophisticated data structures and algorithms that exist that underlie a lot of what goes on in computing. So hopefully you'll get a deeper understanding of computing and maybe even a little bit of a computer science-y feel for things as a result of going through this lecture. So hashing, what is hashing? Hashing is a function, which means it's taking some kind of an input and turning it into some kind of an output. And it takes a value, we call it a key value, I should say, which is typically some group of characters, oftentimes like a string. And then it calculates or maps it into another value, which is called a hash value. And that value has a specific length to it. It's of a particular size. And so that's essentially what hashing is in general. And as I said, hashing applies to a whole lot of different purposes, and we're going to be looking at some of those. So some of the characteristics of a hash function, as I said before, all of the outputs are the same length. Another thing, it's deterministic. What I mean is, if I give it the same input, it's always going to give me the same output. Another thing is, it's one-way street. In other words, I can go from the key to the value, but given a hash value, I can't figure out what the key was from that hash value. That has some implications, as we'll see. Hashing can't be used for encryption. We'll talk more about that later. But it is very useful for other security purposes, and we'll talk more about that as well. Another thing is, it is possible for two different keys to come up with the same hash value. One of the things that determines how likely you are going to have such collisions is the size of the hash. If it's a tiny little hash of only a couple of bits or a few bits, then you're going to have a lot of collisions. If it's a big hash value, and as we'll see later when we get to looking at cryptographic hashings, there are some cryptographic hashing algorithms that produce a 256-bit output, and that's a pretty darn big output. And so in a case like that, the likelihood of collisions is obviously much lower. Even if you do have collisions, there's ways around it, as we'll see, and sometimes it doesn't even matter, as we'll see as well. But we'll talk more about that later. So hashing is used for a whole lot of things in computing. There is actually a hashing data structure that is used all over the place. We'll see some examples of that. It's another example of kind of a collection sort of data structure. And we looked at arrays. You've seen arrays as collection sort of data structures. You've kind of explored the idea of a stack because you know about the call stack, the program stack, the frame stack, and that's another kind of a collection of things. And a hash, whether it's a hash table or a hash map, or there's a lot of different words for variations of this theme, these are collection data structures. It's often really used underlying databases. You know, we may think of a relational database in terms of tables, rows and columns and things of that nature, but that's kind of an abstraction. Lying underneath it is a deeper structure closer to the computer, if you will, which often involves hashing. And as I said before, it's used for security purposes, and there's all kinds of other purposes as well. And, okay, well, I guess what this slide is talking about is kind of contrasting the structure of a hash function format for storing data to either a relational database or something you might find in HTML, which is kind of a hierarchical data structure. So all of these are different ways of structuring data, and hashing is one of these ways. Notice the notion of you have keys, and then you have a function, and the function results in a value. And so the data that we would put associated with this key. Think of the key as if it's a primary key kind of thing. So that's the unique identifier. So the value, where do we store this in whatever this structure is? We call them buckets, and the bucket is associated with whatever the function translated the key into, and that's the kind of idea behind that structure, as opposed to these structures, or for that matter, as opposed to other structures that you're already familiar with, such as arrays or stacks or things like that. Now, as I said, it's possible for two keys to result in the same hash value. We see an example of this here. Looks like John Smith and Sandra D. both went to the same bucket, if you will. So when you have that situation, and therefore you're going to have maybe a number of records that would be in that same bucket, so that the keys are going to take you right to that bucket, well, what can you do? You can make a list of them where one points to another. We see that sort of thing. Now, when we're talking about a list, often the term is used linked list. That's exactly the data structure that if you were taking CIS 221 and you worked with Python lists, that's exactly how things were stored. The idea of one item pointing to another. Under the hood, you don't really see that, but that's the way that in memory things are being stored. One item is referencing another, which is referencing another. And you already know about the idea of references. You can imagine that this sort of thing can take place in the heap, for example. So this is just another example of that. But the point of this is that if you have collisions, then what do you wind up having? You're having a bucket that has a list of items that belong to that bucket. So that's something having to do with using hashing for storage of data and for the ability to quickly access data. And as a matter of fact, before there were relational databases, the relational database idea started to begin to become the norm probably in the 1980s, mid-1980s. Prior to that, certainly there was such a thing as databases. If you took 330, then in the textbook they talk about the history of database structures. Well, one very common file organization for storing data in databases is a hash file organization. As a matter of fact, when I first started working in the computing world, I worked for a company called Michigan Bell Telephone Company. This was back in the old days of the telephone industry, before we had our Verizons and our Sprints and all the rest, certainly before there were cell phones and stuff of that nature. Basically, in those days, the telephone company was kind of a quasi-governmental monopoly. So there was AT&T, which we called Ma Bell, and then there were the Baby Bells, of which Michigan Bell Telephone Company was one of them. Each state essentially had its own. It was a utility. It was a highly regulated utility. And so I worked for one of the Baby Bells. And the database that we had was a hashed file organization. And we called it BFITS, which stood for Big File in the Sky. Now, right around that time, relational databases were starting to come into play, and Michigan Bell was starting to use relational databases. But all of our customer data, all of our data having to do with all of the telephone equipment and the lines and the routers and all that kind of stuff that you can imagine that the telephone companies have to manage, all this hardware, all this infrastructure, the data for all of that was stored in BFITS, which was not a relational database at the time. So relational databases, of course, have grown to become the norm now, but it wasn't always that way. And as a matter of fact, if you still have your database textbook, one of the chapters of the database textbook has to do with something called physical database design. We don't really stress this in CIS 330, but they talk all about these kind of underlying data structures. They kind of are below the surface of things like tables and rows and columns and primary keys and relationships between tables and things of that nature. That's kind of a level of abstraction higher than and sitting on top of things like these other file organizations, of which hash file organizations or others like indexed or sequential or bitmap kinds of organizations are. So our whole idea of a relational database is not really at the computing level per se. It's kind of at a layer above it, and one of the things that it stands upon are these kinds of file organizations. If you were a computer science major, you'd be delving a lot deeper into this stuff. As a matter of fact, now in the age of big data, there's kind of this emphasis on something called not only SQL. You may have heard of it, NoSql they call it. It doesn't mean no SQL at all. It just means not only SQL. And one very common kind of data structure in this kind of environment, and it's one that's very amenable to high volume data that's stored in the cloud sort of thing, is key value. And kind of an extension on that is the idea of document store databases. Very common in the area of big data, and these are built, in fact, on top of the idea of hash data structures. And two examples are MongoDB, which is open source, and DynamoDB, which is part of Amazon Web Services. And if you take the business intelligence course, BI, which is CIS 463, perhaps you'll learn something about these other kinds of database structures. And you can see that also in programming languages, we see this notion of key value data structures a lot. A key mapping to a value. And in Java, there's hash maps and hash sets and things like that. We're actually, even for your assignment, you're going to be seeing making use of that. You're not going to have to create it yourself, but you'll be making use of existing functionality for that, for being able to do cryptographic hashing, as we'll talk about. In Python, you learned about lists, but you didn't learn about dictionaries, and that's a very important data structure in Python. If you go further into using Python, I'm sure you will start to make use of dictionaries, and that's another key value kind of data structure. And in JavaScript, there's this notion of JSON, JavaScript object notation, and that kind of syntax is, again, a key value kind of idea. So it's all over the place. And there's some classes in the Java class library. There's something called map, which is not really a class, it's an interface. We'll talk a little bit more about interfaces later on. There are also these abstract classes. Now we're going to have to talk about what an abstract class is later on. And then there are the kind of classes that we're making use of right now. They're actually concrete classes, one of which is hash map, and there's hash table, and there's hash set, and things like that. There's some examples in the chapter 21 of the textbook if you're interested. We don't really need to go into these in detail right now, but that textbook has a whole lot of stuff that goes way beyond what we do in class. And here we can see kind of a hierarchy. This, by the way, is what's called a UML diagram, hierarchy of these classes and interfaces. We'll go more into UML stuff later on in the semester. So at some point, maybe I will talk about some of these examples from Chapter 1, but for now, let's move on and talk about hashing, not for storing data, not for the purpose of storing data that can be quickly accessed and things of that nature, but for the purpose of computer security and specifically for the notion of cryptography. And when we talk about cryptography, the idea is we're talking about obfuscating things. We're talking about scrambling up a message so somebody who should not be able to read that message can't. And one of the reasons that we might do that is if I want to send a message to a friend and I don't want anybody else to see what that message is, I might want to do some cryptography. That's not really what hashing is for. That's called encryption, which is something different. We'll talk about that. Hashing, remember, is a one-way street. So if I was going to hash my message, well, not only would the bad guys not be able to read it, but even my friend wouldn't be able to read it. And that's not what I would want in a situation like that. But for some purposes, it makes a lot of sense. For example, a password. Nobody should be able to read my password. Encrypting passwords isn't the thing to do. Making them completely unable to read them is the thing to do. And there's no going back. I shouldn't have to be able to say, what's my password again? If I forget my password, they don't tell me, hey, here's your password. They tell me, here you go, make a new password. So cryptographic hashing is supposed to be a one-way street. So the cryptographic hashing is kind of described in the slide. You can also add what's called a salt value to add more confusion to it. There's all kinds of ways to try to make it more and more secure. As I said before, it's possible for there to be collisions. But first of all, as I also said, unless you got a lot of collisions, it probably doesn't matter. I suppose if somebody's trying to crack your password and they keep banging away at it with all kinds of possible values, eventually they might get a hit, and it might not really be your password, but they can get in anyways. But however, keep in mind that these hash algorithms, these cryptographic hash algorithms, produce very, very, very big values. And so the odds of getting a collision is kind of low. So that's one of the ideas behind that. This was kind of showing the distinction between cryptographic hashing and encryption. So with encryption, you encrypt, you get your garbled up message, and then you can decrypt, and you get your original message. There's no such thing as that in hashing. There's no decrypting in hashing. So SSL, secure sockets layers, uses encryption, and it's used all over the place. If you are going to be doing application development in a real-world environment, there are going to be times when you're going to want to use encryption. You're going to want to encrypt sensitive data. For example, you might want to encrypt somebody's social security number. Yeah, encrypt it. So it's hard to get at it, but you got to figure out what it is at some point in time. So you got to be able to decrypt it. But the password is something different. The password, you want to hash it so that it is garbled up, and nobody should be able to ungarble it. Nobody should ever be able to ungarble it. Even you. If you forget your password, make a new password. This kind of shows some of the different encryption algorithms. This link, let me pull it up. And all of these different encryption algorithms, MDA, SHA, of different varieties. And if you look at the sizes of these, 128, 256, 256-bit would be the hash value. That's 32 bytes. 2 to the 256 power is a big, 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 big number. That's why I say the chances of collisions are fairly low in something like that. So that's an example of a hash algorithm. Now, obviously, we don't have to write our own hash algorithms. We can use existing hash algorithms, and that's certainly what the idea will be in your assignment. Stuff from the Java class library that implements some of these hashing algorithms. One of those hashing algorithms is called SHA-256, which produces a 256-bit hash for a given string input. And we're going to make use of that in your next assignment. And I think this assignment is a pretty complex assignment, so I think I'd like to go through and give you an idea of what the expectations are for the assignment, and then we'll talk about some of the cryptographic hashing mechanisms that we can use to accomplish some of this. So here we see the assignment in Canvas, and there's a rather lengthy PDF document that gives us this. And we'll look at this PDF document a little bit, but I think what I'd really rather do, rather than read the document for you, is to actually run the code so you can run the program so you can see what's expected from it, and also to illustrate hashed passwords that are being stored in a file. So we'll start doing that. So I'm going to just run my solution, and we'll see what that solution is doing. I'm going to go ahead and execute it. And as you can see, we have a number of possible choices. And one of those choices is to test a password. And the password is going to have some criteria for being valid, similar to the criteria that JMU has for their passwords. You have to have a minimum of 8 characters. You have to include both letters and numbers. You have to include both lowercase and uppercase in your letters, and you also have to have at least one special character, an exclamation point or a pound sign or a percent symbol or something like that. Also, there can be no spaces in the password. So I'm going to try a couple of them. I'm going to do one, test a password. I'll try a bad one, bad PW, and as you can see, it's a bad password. Let me try one that's better. I'll try putting in a better password than that. Let's try bad PW, and it has numbers and it has capitals, but still it's a bad password. Let's try one more. I'll put something, I'll just call it, I'll just do one password exclamation point, and we have a number, we have upper and lowercase, it's more than 8 characters, and we have an exclamation point, and it shows that it's a good password. So that's part of what I'm going to ask you to do. Now, accomplishing this task doesn't really require anything from the security features of Java. Really, all it requires is for you to look at a string and make sure it meets the criteria. There are some useful methods of the character class, capital CHARCTER, which is a class in Java that can help you with that. And other than that, it's all about kind of string manipulation stuff that you would have learned about already. So this first task, while it's not an insignificant task, is also not something that makes use of material that you haven't already learned. You'll notice that you're also going to be reading and writing files. So let's read a file. Let me show you a file that I'm providing for you as a sample file. Here in the assignment, you see there's this file called users.txt, so you should be able to download that file. And that file, if you're going to be using it in your program, as you know, a file, you would store it in the root of your NetBeans project. And if we look at the contents of this file, you can see that the file basically is going to have some number of lines. In this case, we have just 2. And within those lines, there's going to be a string that's separated by a space. Before the space is the user ID, and after the space is the hashed password. So let's take a look and see what we mean by this hashed password. As I said, the algorithm that we'll be making use of is this SHA-256. That produces a hash of 256 bits. Remember, a hash function always takes whatever the input is given and produces a fixed length output. And in this case, the length is 256 bits. Now, 256 bits is 32 bytes. And within a byte, you can have basically any number between 0 and 255. If we were going to represent this in hexadecimal notation, which is base 16 notation, then you would wind up having 2 hexadecimal digits for each byte. So if we have 32 bytes, that means we're going to have 64 hexadecimal digits. And here we see 64 hexadecimal digits. Remember what hexadecimal is. Hexadecimal is base 16. You would have learned that somewhere along the way. In base 10, we have 10 possible digits, 0 through 9. In base 2, which is binary, we only have 2 possible digits, 0 and 1. In base 16, we have 16 possible digits, 0 through 9, and then A represents the number 10, and B represents 11, and C represents 12, and D represents 13, E represents 14, and F represents 15. And so you can see we have some A's and B's and C's and D's and E's and F's in this string. So there are 64 hexadecimal digits, which represents 32 bytes of data that has been produced by the hash function, and that's what we see being stored in this file. So another task is actually to read a file. Well, you did that already. And it will be very simple to read the file and then to populate an array with the contents of this file. You'll create an array that's big enough, kind of like you did in the last assignment. You can make the array 10 or 100 or whatever arbitrary length you want. It's only a single array that you need, just a string array, and you will read into that string array. So assuming that we are talking about the users.txt sample file, I'll go ahead and do the choice to read a file. It's going to ask for the name of the file. I'll say users.txt. And it said that I read the file. Well, if I read the file, it would be read into an array. I should be able to list all the users in that array, so I'm going to pick number 4 now. And I pick number 4. And simply it's reading that exact same stuff that's from the array. So reading the file and listing the users, that's a pretty trivial thing to do. A more complicated thing to do is to actually try a login. So here we have these two users, user XXX and user ABCD. And we have all of these hashed passwords. Well, what are these passwords? There's the XXX password is, as it turns out, just one password exclamation point with a capital P. Let's try doing that one. So I'm going to log in. I'm going to give XXX as my user ID, and I'm going to put one PASSWORD exclamation point. And you can see the login was successful. In other words, when the hash algorithm was applied to this string, it produced this output up here. And I matched it with what was in the array for that particular user, and it was successful. Well, let's try another one. Say I'm going to try another user login. And this one I'll put YYY. And I'll even put the same password. But YYY doesn't exist. And so we can see that the user doesn't exist. Well, that was pretty simple because I was just searching the array to see if the user exists. Let me try putting XXX again. So I'll again do a user login. I'll put XXX, and I'll put a bad password, something that doesn't even legitimately qualify, which is the same kind of test that we would have done for the first option right here, test a password. And it says that this is an invalid password. Let's try this. Let's put XXX. Oops, notice that when I said XXX, it said invalid entry because it was giving me a menu. So, at least it's checking that and making sure I've got bad, that I'm going to go back and give the menu again. Let's do this again. User login, 5. Let's try XXX again. And let's try a password that would be a legitimate password, but it's not the right password. So it's going to have a number in it. It's going to have a bunch of letters, some of which are capital, and it'll also have a special character. And, well, it's a legitimate password, but it doesn't match the user ID. So that's another possibility when you try to log in a user. And then finally, the last option would be it's right, as I said before. I'll put it for the other user. Let me do a list again so you can see the users. So there's a user called ABCD. As it turns out, ABCD's password is JMU Dukes with a capital D, and then the numbers 1 and 2, followed by an exclamation point. And so I'll go ahead and do that. I'll try to do a user login, ABCD, And the password, JMU Dukes 12 exclamation point, and voila, the login was successful. So there's 4 possibilities here. Either the user doesn't exist, or you have a completely invalid password, or the user does exist but the password doesn't match, or the login is successful. So those are the options when we try to do a user login. The final option is to add a brand new user. And when you try to add a user, there's a few possibilities. One possibility is that the user already exists, so we can't add a user that already exists. Another possibility is that when we're adding a new user, the password that you tried to give is just not a legitimate password. You can test for that as well. Or finally, the user doesn't exist and the password is legitimate, in which case you can now add the user to your array of users. So let me try doing something like that. So I'm going to try this. I'll try to do XXX again. I'll even give it a good password, but it's going to say that the user already exists, so it's not going to let you do anything. Let me try another one. I'll do another 6 here for adding a user. New user. I'll give it a good password. I'll give it PASS capital WORD question mark 9. And I'll enter that. And it looks like it was added. As a matter of fact, now if I list my users, you'll see that I have added this new user to the list with its hashed password. If I try to do a login with this new user, and I have to remember what the password is, which was this, and the login was successful. If I try to log in with this new user, and I gave something that wasn't right, even if it was legitimate, it's saying it doesn't match. And then finally, I should be able to write the file. If I write the file, and I'll call this now users2.txt, and it says it wrote it, and I should be able to actually go into the folder. I will do that. And here's users2, which was just created, and there it has the data. So that's basically the expectations of what this program is supposed to do. And of course, finally, the last option is to quit. I say 7 and quit. It tells me goodbye, and the program terminates. So for much of this, a lot of it is review of what you've already done. You've already read files. You haven't actually written a file, but we went through some examples for doing that. Makes use of the print writer method. Go back through the strings and file I/O, text file I/O lecture and notes to see how to do these things. Listing the users is basically just looping through an array. Testing the password, as I said, is a little bit more complex, but there's some very specific criteria that you can go by, which I've told you and which you also can read in the assignment document. So none of these are all that complicated. The user login and adding the user is more complicated, but particularly because here's where we need to make use of the hashing algorithms. So we have an idea of what the expected behavior is of the program. We're going to need to do some cryptographic hashing or make use of cryptographic hashing. There is some useful sample code that I made use of in my solution. It's at this link. And this code is making use of the message digest class, which I had described in my previous video. And one of the algorithms that it makes use of is this SHA-256. And here it is. It's a full Java class. It even has a main method that you can run. But more importantly, it has these two methods, getSHA and toHexString, that you can make use of. And I'll kind of show what it does. In order to do that, I think what I'm going to do is I'm going to start off by making in my assignments project, I'm going to go ahead and make a new package, and I'll just call my new package assignment 4, but I won't spell it all out. I'll just say ASSN4 since I already have an assignment 4. I'm going to go ahead and do that. And you will notice that in this, going back up to the sample code, which we'll delve into a little bit, I can copy this code and I can use it. So I'm going to go ahead and copy this code. And I'm going to make a class exactly the same name called GFG. And I'm going to put it into, my NetBeans package that I just created. So I'm going to make a new class. I will call it GFG, just like the other one. And it made this empty class. I'm just going to go ahead and copy and paste this code right into there. And you can see that it's importing some stuff. We don't have to worry too much about all the stuff, except to note that there's your message digest, right? And you will notice that in the main method, it's actually got a string, and it's going to print out the string's value and its hashed value. So the string is the key, and then the hash is going to be the value that comes from the key. Remember that hashing is this key value type of function. And we got one that's geeks for geeks and the other that's hello world. Let's see what it produces. I'm just going to go ahead and execute this. And there it is. Here was the string, and here was the hash that resulted. A hash of, as we've said before, 256 bits, which means 32 bytes, which means 64 hexadecimal digits. And we got it for this and we got it for that. So what did this program do? Well, it's making use of these two methods. And these two methods, one of them is making use of message digest. And looks what it's doing. It's saying, I'm going to load this algorithm, SHA-256 algorithm, and then I'm going to call for it a method called digest, and I'm going to basically give it the string input and get the specific bytes from it, pass it to this digest, and then it's going to give me a byte array. We don't have to worry too much about the implementation details, but let's just at least get an idea of what it's doing. And then there's this other method called toHex which is taking the byte array and actually generating the hexadecimal digits, and it's making use of a few other classes for doing that. We don't really have to worry about all the details of that either. So what's the main method doing in each case? It's calling getSHA, it's passing the string, that's giving us the byte array, and then it's taking that byte array and passing that to this toHex string, which is giving us a string which is going to wind up being the hexadecimal digits. So in principle, you pass your password to get SHA, which gives you the byte array. You pass the byte array to toHex string, which gives us the final hashed value. So given that we have this class and we can work with this class, and this class is going to be in the very same package as our application class, I'm going to go ahead to this package and I'm going to make my class that's going to be my assignment class, or at least the beginning of it. I'm going to make a new Java class. I'll call it login. Okay. And I'll click finish on this. So now I have this login. I'm going to go ahead and just make a very simple main method. And in that main method, I will in fact make use of those methods of the GFG class. Even though GFG is a class that itself has a main method, we don't have to use it as a program. We can use it in another program, and we can just make use of these methods. Given the fact that it's in the same package as our application, then we can have easy access to it. So I'm going to make a main method, public static void main string, open bracket, close bracket, args. And here we have this. And I'm going to go ahead and kind of do this piecemeal. I'll make my byte array. I'll call it bytes. And I'm going to use, from my GFG class, this getSHA method and pass it a string. So I'll just say I'm going to go to the GFG class. I mean, when we're talking about calling a static method from a class, you've done that before. For example, you called math.pow. So pow is a static method of the math class. So you gave it the class name followed by the method name. So I'll do the same kind of idea here. GFG dot, and what do I have? I have all of these options. I'm going to call getSHA. And I'll go ahead and put in a password. I'll put just one password exclamation point, which is the same one that our XXX user had. Let me fix this. And so this is going to give me the byte array. And then I'll have string hashed PW equals, once again, GFG. This time I'm going to call toHex string, and I'm going to pass this array bytes to it. And then let me go ahead and print it out and see what it gives me. System.out.println hashed PW. And let's see what this is not like. Oh, I also notice I'm getting an exception here. So we have to catch the exception. So let me do this. Try. And then at the bottom of that, I'll put a catch. And then I'll just do a print. And then whatever, I could say e.toString. Which would give me an error message, if there was one. Give me the specific error message. Let me go ahead and run it. And in this case, we didn't have an error message, and it produced this hash, which if we go back and look at the text file again, let me pull up the text file, is exactly the same as the one that was for XXX. So there you can see how we can make use of the hash algorithms that already exist, and hopefully this sample code will be useful for you. And you're going to need this sample code for two of the tasks. One is the task that where the user attempts to log in, and the other is the task where you try to add a new user. In both cases, you have to generate a password. So to recap the assignment, if you look at the document, the PDF, you'll see the expected behavior is exactly what I was just showing you in the video. You'll note that for testing the existing data, you can see that this user has that password and the other user has this password right here. You can see different circumstances for either a user login or adding a user, or for that matter, testing. You can see some samples of where you had bad passwords or good passwords. Reading files, listing the users. Here we had the user list with two different users in it. So you can see all the expected behavior. That's all described. The importance of exception handling and making sure we're dealing with errors. That's going to be true from here on out with your assignments. And here, basically, I'm giving you the headers for each of the methods. So you can see what it's expecting to take as a parameter. You can see what it's expecting to return as return values. And there's a description of what each of these do and how you use them and when you're going to use this GFG class. There's also some things to consider. None of these methods is going to do any user I/O. Nothing is going to write to the system.out. No method other than main is going to write to system.out or read from system.in. All these methods are going to do is take parameters and return values. Some of them are easier than others, so I'm suggesting that you tackle the easy stuff first. And, of course, you're going to be making repeated use of methods, especially this isValidPassword. You're going to be making repeated use of that. So don't reinvent the wheel. If you already have the code, that's the whole idea of a method. If you already have the code, you call the method. You don't rewrite the code. Talks a little bit about what the main method is doing, the overall structure. You've got a loop. You're presenting a menu. When the user selects something from the menu, there may be some other inputs. In most cases, there will be some other inputs that the user has to give, and that's the main method that's going to handle all that user I/O, as I said already. And then finally, what are the deliverables? You're going to have a package. It's going to have these two files, the GFG class and the one that you're writing on your own. I want you to set a breakpoint in your debugger within a method that's been called, so we're going to be able to see the call stack, and also for the call stack, the local variables as well for the method that we've got the breakpoint in, so you can show me that that's taking place. Give me a little description of that. And one last thing you're going to do is you're going to draw a diagram, and that diagram is going to be a top-down structure chart, similar to the technique that we saw in Chapter 6, but this is going to be of your assignment, of your program. And so those are the deliverables for this assignment. It's going to be a lot of work, but if you get a good start on it, and if you keep working on it diligently for the next week and a half or so, which is how much time you have for this, then I think you'll be able to do fine. And of course, if you have any problems, you'll be able to talk with me about these during office hours or email or whatever. So that's what we've got for this assignment, and I wish you the best of fortune with it.